Hello, everyone. So we have another potential snowstorm coming up for the middle of the week. I'm going to be completely honest. I am extremely confused by the setup. I'm not entirely sure about why there are certain differences in the storm track and intensity, and usually I'm able to tell by looking at the 500 millibar, but I'm having a lot of trouble. So I'm going to do my best here. This video could easily end up being 20 minutes. I'm going to try to keep it to 15. Um, so, this might get a little confusing, so I apologize. But let's try our best here. So, what I'm actually going to do, I'm going to do something a little different. I am going to show both the NAM and the GFS in this video. We're going to look at the surface map first. I'm going to go over the differences in the surface map, and then we're going to go back to the 500 millibar vorticity and try to point out differences in the circulation aloft that might lead to the differences in the surface map in the models. Okay, so this is the NAM, so let's just go through it once to get an idea of how this is going to play out. So this is Tuesday morning at about 7 a.m. So you have your initial storm here over the Great Plains. You have your surface low, 1,001 millibars. You have precipitation with it and everything. Now what's going to happen as we go through the day, this will move to the south and east fairly quickly. And then, so here we are, this is Tuesday evening. Now watch this translate to the south and east and reform off the Carolina coast. And there we go. So, from late Tuesday night, here it is. It's right over the Ohio Valley, and bam, it reforms right off the Carolina coast. Then what's going to happen is this storm will move to the north and east up the coast and produce a snowstorm, as you can see here in the NAM. Okay, so that's the basic idea. All right, I'm going to bring it back to this. Okay, so that was late Tuesday night. So now we're going to look at the GFS. Okay, so here we are. GFS, NAM. GFS, NAM. Okay, so now the GFS is different from the NAM with the storm in that the GFS is holding the storm closer to the coast and further to the north and west. That's difference number one. Difference number two, it's not as strong with the storm. So if we look at the GFS first off, here's our surface low. Look where it reforms. It reforms off the coast of Virginia. And the NAM has it reforming off the coast of North Carolina, much further south. So that's one difference already. And also pay attention to the millibar numbers. We have 1,003 here, 1,002. Watch as the storm is going to strengthen. So let's go forward on the GFS. Here we go. Wednesday afternoon, we're down to 997, and look how close it is hugging the coast. Let's go ahead 2 steps on the NAM, 998. Look where it is. It's all the way off to the south and east still. It's not hugging the coast. And so the reason that's important is because if this hugs the coast like the GFS is saying, then warm air is going to be pulled further inland and less snow along the coast. Also, again, pay attention to the numbers. So right now the GFS is at 997 and the NAM is at 998. Now, right now the GFS is stronger, but that's going to change. All right, now we're down to 995, and again, look, it's literally right over Atlantic City, the low pressure. And the NAM, we go ahead 2 steps, and look at that. We're down to 990 from 998. So much stronger. It is close to the coast, but it's not as close as the GFS has it. GFS is further north and west. And because of that, you can see that you have rain spreading inland into New Jersey, Long Island, into New York City, coastal Connecticut. These areas are all receiving rain. And on the NAM, it's all snow. And there's a couple of reasons for that. Not only is the GFS closer to the coast, but as we can see here, go ahead 2 steps, the NAM is stronger. Now we're down to 985. That is by Wednesday evening. And now we're only at 990 here with the GFS, and look how far inland this rain is getting. And part of the reason for that, in my opinion, there's a couple reasons. So, first of all, when you have a stronger storm, a rapidly intensifying storm, it's my thinking that this cold air that's going to be in place up here across New England is going to wrap into the storm from the north and west more efficiently if the storm is stronger. However, if it's not as strong, like the GFS suggests, then the cold air is not going to wrap in as efficiently. It's going to stay back further to the north and west. And you still have to worry about warm air coming inland as well, especially if this is closer to the coast. So you want this storm, if you want snow at the coast, you need the storm to be stronger, and you need it to be further away from the coast. If you want snow inland, then the GFS is your gem solution right now. Okay, so that's the surface map. Now let's go to the 500 millibar. Okay, this is, let's go to Tuesday morning, 12Z. Give me a second here, 36. Excuse me. Okay, here we go. So here's our 500 millibar, and here's the setup. It's a very interesting setup. Alright, here's the GFS. So the general setup is that you're going to have 2 areas of, 2 upper lows. You have one over Canada here. Oh, I don't like that color. Let me change this. Much better. Okay, so you have an upper low over Canada, and you have an upper low over the Great Plains here. Still don't like that color. Hold on a second. Let me see a good color here. All right, blue's good. Okay, so here we go. So this is the GFS. And here's the NAM. So not much of a difference. You have your upper low over Canada, and you have your upper low over here. Now what's going to happen is this low is going to translate to the south and west. This low will continue to translate to the east, but they're sort of going to be together in one circulation. And so what ends up happening is this northern upper low over here will guide this upper low around the bend and up the coast. Okay, so that's the general synoptic setup. But there are a couple of differences that I want to note here, so let's just go through. Notice how here you have a distinct southern upper low and a distinct northern upper low. And then all of a sudden, when you go past Tuesday here, that distinct closing off of the southern upper low is gone. See that? The isobars, there used to be circles of isobars down here, meaning that the southern upper low was closed off. But that disappears by Tuesday night on the GFS. Now the NAM has a different solution. As you go through Tuesday night, we're going through Tuesday night, see, it's still here. So you still have a potent southern upper low. You have two distinct upper level lows. And this one is still strong too. And as you keep going forward, it still doesn't disappear for quite a while. It's still there. You can still see that closed off isobar. But on the GFS, it's not there. It's gone. You just have this one upper low to your left, which is the steering mechanism for the storm. So now, keep in mind that all of this energy to the south on both models is what's going to create our storm off the coast of the Carolinas or Virginia, depending on which model's right. Okay, now, my thinking with this setup is the fact that on the GFS, your southern upper low is sort of absorbed by your northern upper low. So my thinking is that the steering mechanism is going to be dominant in the circulation in the GFS's solution. And so that a lot of this energy is not going to be translated as far south and east as in the NAM. So that's one thing. So just look at this energy here. If you go to the NAM, look at all the dark reds that are much further south and east. Thus your storm forms further south and east. And then the other thing to notice about this, and this is a pretty big difference. Sorry. Now we're in the same time step. Okay. Look at the tilt of the trough axis. This trough axis is still positive on the NAM. And the trough axis on the GFS has gone neutral to slightly negative, and this is by Wednesday afternoon. So that's another reason that this storm hugs the coast. Excuse me. That the storm hugs the coast on the GFS more, is because the trough axis has gone negative quicker than on the NAM. If you could see what I'm talking about here. Not by much, but enough that storm track is key. So now as we move forward here, let's go to Wednesday evening. So now on the NAM, your trough axis has gone negative, which is good. You want a negatively tilted trough that comes up the coast, but you don't want it to be too negative so that it comes up the coast too much. See, I'm still trying to figure this out as I'm looking at the video. As I'm doing this video, I'm still trying to figure this out. Alright, NAM, GFS. NAM, GFS. NAM, GFS. Okay, so now one thing to notice is this energy here, this is the NAM. It's south and east off the coast. If I go back to the GFS, notice how it's hugging the coast. It's slightly further to the north and west. Okay? Now we go ahead one more step. And just look at all of this energy in the NAM that is right off the coast. And now your low has closed off as you see the closed 528 contour. So the NAM, again, the lower the number here, the stronger the system is. So you see this large 528 closed off contour here, which means the storm is rapidly strengthening. And then on the GFS, you see the 528 contour sort of starting to form here. You have 534. This is the 528 contour. And also notice that it's further north and west. It's right over Long Island, as opposed to centered just south and east of Long Island, like on the NAM. Okay, so to summarize my thinking here about this setup with why there are some subtle differences in the storm track with regards to the NAM and the GFS. So the GFS, as I said, I think the reason that everything stays further north on the GFS is because the upper low to the north dominates the flow, and I think less energy gets translated to the south and east. So if we just go back one more time, see, I think this dominates the flow. But on the NAM, if you go back, you still have this southern upper low here. You still have it. It does not get absorbed and disappear. It stays for quite a while. And overall, you just have more energy further south and east. You have all this energy here. So, very, very complicated setup. Okay, we're already at 17 minutes, and there's still quite a bit to talk about here. I'm going to keep going. So, the other thing about this storm is the thermodynamic aspect, the temperatures. Okay. Hopefully this will only take another 5 minutes. Alright, so let's just look at this. So, looking at the NAM and the GFS, what day was this? This was Tuesday night. Let's go to Tuesday morning. Okay. So, there's a couple of things to notice here about the setup. So first off, here's your surface low. This is the initial low that forms. In fact, blue is not a good color now, so I'm going to switch back to red. Hold on a second. Alright, here is your surface low. And keep in mind that before the surface low reforms off the coast of the Carolinas or Virginia, it's going to be pulling up warm air from the Gulf, like this. As you can see, you see these greens and these lighter blues being pulled up into the northeast. That's because that's how the flow around low pressure works. It is counterclockwise, so obviously as the low moves east, it's going to be pulling up warmer air. Now, as we go forward here, trying to keep this short and sweet. Go to Wednesday night. If you notice something, so the placement of the low and the strength of the low, the surface low, before it reforms off the Carolina coast is pretty consistent in both models. However, on the GFS, the surface low seems to be a little more efficient at pulling up warm air. You see these greens and these lighter blues making it further north, all the way up into the Ohio Valley and into southern New England here. You have these greens and blues, these sub-freezing and above freezing temperatures pushing further north. in the GFS than in the NAM here. The green is, the 0 line is slightly further south. In fact, quite a bit further south, if I'm correct here. Yeah, actually quite a bit further south. So before it reforms off the coast, the GFS tends to think that the surface low will be pulling up warm air more efficiently. Then it reforms off the coast, and all this warm air is still here. So now as we move ahead here in the NAM, and it reforms off the coast, the thing to notice by Wednesday evening as this is starting to bomb out is that you still have this tongue of light blue pushing all the way up. These are sub-freezing. Now keep in mind that this is aloft. This is not at the surface. So in these areas, it is quite possible that it is above freezing at the surface. You have this tongue of lighter blue pushing up further north and east. Meanwhile, in the NAM, you see how the darker blues have all but pushed to the south and east, and there's no lighter blue here. So it's colder. So overall, the NAM has a colder solution than the GFS. And I think the reason for that is because in the GFS, the surface low before it reforms off the coast was more efficient at pulling warm air northward. And then the other thing to notice is this high over the western United States here. Now the flow around an area of high pressure is clockwise. So this here is going to be pushing the colder air from that's all across southern Canada here to the south and east. Now in the NAM, I won't show it because we're already at 22 minutes here and we got to wrap this up. The high is slightly stronger, and so I think that because this high is slightly stronger, that this cold air is pushed further to the south and east. So those are all my thoughts about the synoptic setup. Okay, so to summarize, we have a storm coming. There's a lot of differences, key factors, you know, a lot of things that can make or break this for the coast. Storm track, boundary layer temperatures are going to be big. If the GFS is right and there's more warm air in place, then snow is going to have trouble accumulating on the ground, especially at this time of year. If the NAM is right and there's more cold air in place, then I don't think boundary layer temperatures will be a problem and there will be more snow accumulation. Okay, so my threat area is going to be something like this. Okay, this is threat area for heavy snow. I'm going to say this is a threat of 4 inches plus. And I'm afraid to go any higher just because I'm afraid of boundary layer temperatures and storm track. So this will be your threat for 4 or more inches of snow. I'm including Baltimore, Washington, D.C., Philly, New York City and Long Island, Boston, most of Maine. Albany I'll keep on the northern edge of this for now. I think you might be a little too far north. Providence, Rhode Island, Hartford, Connecticut, all of New Hampshire, southern Vermont, eastern and northeastern Pennsylvania, all of New Jersey. These areas, I'm putting you in the threat for 4+ inches. Now, if boundary layer temperatures are below freezing or at freezing, then there's going to be a lot more than 4 inches of snow. That's just because when you have a rapidly intensifying area of low pressure, like this, you always have to watch on the northwestern side for the heavy precipitation. And storms like this are notorious for producing unforecasted heavy precipitation, usually in the form of snow. So if boundary layer temperatures are not a problem, then there's going to be spots that get a lot more than 4 inches. But if boundary layer temperatures are above freezing, even if it snows hard, it's going to have trouble accumulating. All right, that's it. 26 minutes. I know there was a lot to go through. I apologize that this is so long. I'm hoping some of these details will be ironed out by tomorrow and that I can post a much shorter video, hopefully about 10 minutes long rather than 26 minutes long. Okay, thank you for watching.